Hello, this is Dr. Morales, and in this video we're going to go over transformations on quadratics. This is a skill that is required for the Algebra EOC test. Okay, so first we're going to be using decimals, so we're going to start with the parent function, which is here on red. The parent function is what the quadratic looks like. So in a parent function, the quadratic is when you have an exponent of 2. So x to the second power. So if I was to graph this using a table of value, this is what my graph would look like. When x is 1, 1 to the second power is 1. So that's this point right here. Okay, and then when x is 2, 2 to the second power is 4. That's what point is over here. If I have a negative x, negative 1 to the second power is positive 1. Negative 2 to the second power is still positive 4. But a transformation is when we do stuff to our function that makes it either change how it looks like or move location. Okay, so for example, in here g of x shows the different transformations that we could have. So we can have this a here in the front is multiplies my function. Okay, so if I have to have a number here in front of the x, right now we have an imaginary one, but if I have a number in front of the x, like let's say 2, so that would stretch my graph. So let's see, if I change this a to a 2, look what happened to my graph. It stretched. Remember, my original function is the red one, and the blue one is what happens once I change my a to a number 2. So now it stretches my function. Why? Because if my x is 1, 1 to the second power is 1, but if I have a 2 multiplying, now my order pair changes from 1 to 2. So it stretches. It makes it look like a stretch vertically. What happened if I change that 2 into a 4? What happened if I change it to a 4? Look at my blue graph. It's getting skinnier and skinnier. It's being stretched. Look, as I move it, it stretches. See, look at the blue graph compared to the red graph. Okay, so if my a is bigger than 1, we have a vertical stretch, okay, because it stretches up. But what happens if my a becomes less than 1? Okay, so we're at 1. If it becomes less than 1, look at the blue. Look what happened when it's 1. Look at what happened to my graph. Now my blue one is compressing, so it's getting wider. So see, it's getting wider. Okay, so when I have my a is between is a fraction between 0 and 1, my graph becomes wider. It compresses. You see, this is 0.1, 0.3. So this is what happens to my graph. Okay, so now what happens if it's less than 0? So if it's a negative number, that a becomes a negative number. So look at what happened to my graph. My graph, then it flips. Okay, so now it becomes a reflection. So now instead of opening upward, it's going to open downward. So that's what happens with the a. That's that a that multiplies my function. Okay, so let's go back and let's see what happened to this h and k. This is actually my vertex. So if you look at my parent function, I don't have an h and k because my vertex, if you see here, it's at 0, 0. So that's why h and k disappear. But if I change my h and my k, so let's start with the h. If right now my h is 0, but if I change it to positive 1, look what happened to my parent function. Remember, my new function is going to be the blue. So if I change this to 1, I'm going to change it to 1. H is 1. I still don't see anything. If I change it to 4, and I'm going to change my k. I'm going to change because I had my a. Let's put my a back at 0. So if I change my k to 1, where's 1? Where's 1? Change my k to 1, and I'm going to change this to 1 because I need my graph. There we go. Remember, I had it at 0, so when you have a 0, then it will make it eliminating my function. So look at what happened now. So now my h, so let me write it down so you can see. So now what I did is I have my function is 1 times x, let me use parentheses, times x. My h is 4, so it's going to be plus 4. I have a plus 4 square, and then my k is 1 plus 1. So what happened is my graph moved 4 units to the left and 1 unit up. So you move 4 units to the left, 1 unit up. Okay, that's what that did, moved it. So whatever I'm adding, I'm going to move the opposite way. So I'm adding 4, so I'm going to move 4 to the left, and this number over here, the plus 1, is how many units up is being changed. Okay, so now let's change it. What happens if I do now if my h is -4? So let's go to the negatives. Look what happened. Look at my graph. Look what my graph is doing. My graph is moving now to the right. So if I change it to -4, so instead of x plus 4, it's going to be x plus -4 square. Remember, I just changed my x. My k stayed as 1. So now my graph, my graph moved to the right. So you move to the right 4 units. So my h, if it's positive, it moved to the left. If it's negative, it moved to the right. My k moves my graph up and down. So I have it at positive 1, so it moved up 1 unit. But what happened if I go negative? Let's see what happened. Look what happened as I move down to the negative. My graph is moving down. So here's -2, it moved down 2 units. If I go to -3, it moved down 3 units. If I go to -4, it moved down 4 units. -5, that's -5. So you see, so my k moves my graph up and down. My h moves my graph left and right. We move to the left if I'm adding a positive number. If I have we move to the left if I'm adding, but if we're subtracting, if I have a negative number, then we move to the right. Okay, so let's put it back, let's leave it here. Okay, and my a, just to review, that a is what changes my graph. It makes it either a vertical stretch. If I have a number that is greater than 1, it makes it a vertical stretch. If I have a number between 0 and 1, it's a compression, so it makes it wider. But if I have a negative number, now it flips it down, so now it opens down. Okay, I hope this video helps you understand the transformation on your quadratic function.